Alright guys, this is the second VOD for Unit 6, and today we're going to be talking about solutes, solvents, solubility of mostly solids and liquids this go around, okay? Next time we're going to talk about solubility of gases, but for right now I want to talk about solids. This is something that's going to be heavily tested on the exam, something you need to know a lot about. Okay, so what is a solute, what is a solvent? Alright, so far we've done an experiment on the first day that we got into this unit using Kool-Aid, sugar, water, and trying to make the perfect glass of Kool-Aid, right? Oh yeah! So, we used the solvent of water in this case, and so far you've learned about water, right, and how it is the universal solvent. But today, okay, there are other things besides water that we can use as solvents, okay? They're what we put the solute into, okay? V in the alphabet comes after U. You can think of it that way, T-U-V, okay? So U goes into V, all right? So solute goes into solvent, okay? Solvent is greater in quantity and the solute goes into it, okay? The solute is what gets dissolved, okay? In the image that's shown below, you can see that the solute in question here is sucrose, all right? Sugar. So you put sugar into water, stir it up, alright? Now in our experiment we used the two solutes of sugar and Kool-Aid, right? Put them both in there and made ourselves some perfect Kool-Aid, right? Alright, so take that into consideration as we go throughout this discussion, alright? And solubility takes a turn on that solute, okay? It is the ability of something to dissolve in water. So far we know that it's a physical property, alright? You remember that from Unit 2, alright? Long ago when we started talking about physical properties, chemical properties, the ability to dissolve in water was a physical property, alright? Now, if something can dissolve in water, it is soluble. If something doesn't dissolve in water, it's insoluble, alright? So what happens for something to become soluble is that it interacts with the polar ends of the water molecules that are there. Okay, and as you can see, the chlorine that's on here, the Cl minus, okay, because it does gain a minus charge when it's in a bond, interacts with the positive ends of the water molecule, okay? And then the oxygen, on the other hand, has that negative charge. Remember, they have that polar nature, okay? So that negative end grabs the positive sodiums and yanks them out of there too, okay? And that allows to pick and pick and pick and pick apart the molecule of whatever we're talking about, all right?
Sodium chloride crystals are held together by attractive forces between the positively charged sodium and negatively charged chloride ions. When a crystal of sodium chloride is placed into water, the hydrogen ends of polar water molecules attract the negatively charged chloride ions and gradually surround them. Likewise, the oxygen ends of water molecules are attracted to and surround the positively charged sodium ions. The hydrated ions drift away into the solution, allowing new water molecules to surround newly exposed ions. Gradually, the entire crystal dissociates into solution.
So this rule comes into play here, okay? Like dissolves like. Means that polar substances will dissolve molecules that have charge, all right? Polar substances. So things that are in ionic bonds tend to dissolve in polar substances, like water. Salt is going to get dissolved in water every time, all right? Nonpolar substances will dissolve nonpolar molecules. So things that don't necessarily have a ionic charge to them, if they're more covalent in nature, they'll get dissolved in something that's less polar in nature, okay, that doesn't have that negative and positive charged end. Alright, but if you go to put oil in water, okay, oil is non-polar, okay, oil is non-polar, but water is, alright? If you go to make that happen, it's not going to work, okay? They actually separate into layers. We've seen that before, right? Cooking oil and water, they split, all right? Now, like dissolves like, okay? So the reason that something dissolves is because it is similar into whatever it is dissolving into. The solute is similar to the solvent in terms of polarity, all right? And so, yeah, there's our example of oil and water, and you can see that it's definitely creating a new layer, and even the oil as it goes into the water is kind of beating up because it doesn't want to interact with the water molecules. All right? Now, temperature can also affect what or how something dissolves, all right? So an increase in temperature in terms of solids, all right, will increase the solubility. All right. If you've ever wanted to make really sweet tea, okay, you have to have it very hot before you put the sugar in. All right. I used to work in a restaurant, and so whenever you put the sugar into the tea, it had to be piping hot to get it to the sweetness that the restaurant wanted. All right. And so a decrease in temperature decreases the solubility of solids. All right. If you take a glass of ice water and try to stir in sugar, it works a lot less well than it would if the tea was hot. Okay, so temperature does directly affect the solubility of some solids. All right, and that brings us to the size of the solute. This is the third thing that can affect solubility here. All right, first was nature of solute, then we have temperature, and then we have the size of the solute. Okay, so the larger it is, the less soluble it is. If you take a sugar cube and you set it into a glass of tea, you're going to have to stir for a long time to get that sugar cube to completely dissolve. All right. Now, if you get ground sugar, okay, like you can buy in bags at the store, right? It's a little bit smaller, a little more broken apart, and that allows easier dissolution of it. Now, if you get powdered sugar, okay, the third example here, that's going to dissolve very well. So much so that it's going to make your tea super sweet. All right. So the most optimal way to get a solution of sugar to dissolve, all right, is to have it hot and to have it powdered, okay? And that's to get your tea the sweetest, all right? So think about all that stuff in comparison, all right? We've talked about polar molecules. We've talked about what it means for something to be soluble. We've talked about solutes and solvents. You know that the solute is what you put in, the solvent is what it goes into. You know that temperature directly affects how soluble something is. You know that the size of whatever you're putting into it directly affects how soluble it is too, all right? If you have any questions, tweet me, comment in the comments section below. We're coming for activity period, all right? You guys have a great evening.